Year 4, welcome to your maths lesson for Tuesday, the 26th of January. Today we're going to be doing our second lesson on area. So without further ado, let's get on to our warm-up. So your warm-up for today, how many different ways can you complete this number sentence? And you have to fill in, so you have to fill in the missing numbers. So 25 add something is equal to or the same as 32 take away something. So a little tip, I would suggest that you do put the first number in, put the number in the first box here, and work out what the other number is, and then adjust it slightly, adjust each of the numbers like we've done in class to see if you can come up with some other possible ways. So pause here and have a little go and see if you can make this number sentence make sense. Okay, so let's have a look at some of the possible answers. I thought I'd go really easy on my first one, and I just decided to stick a 1 in there because let's be honest, we don't want to make it too difficult for ourselves. So I did 25 plus 1, and that made 26. And so I needed to make this side make 26 as well. So, wobbly letters, numbers. So then I had to work out how many I needed. 32 take away what would make 26. So I worked out that it was 6 would go in there. So it doesn't matter if you haven't got those numbers. And then what I decided to do was to just adjust those numbers each time so that I could find some other possibilities. So once I have worked out that 25 add 1 is the same as 32 take away 6, then I decided, right, if I put a 2 in this number, so if I put 1 more in this box, then I'm just going to have to put 1 less in this box. So I put 1 more in that box was a 2 and 1 less was 5. So I know that that number sentence is correct as well. Then here I thought, well, I'll just adjust it a bit more. So this time I'm going to put 1 more again in here. So I'm going to change that from a 2 to a 3. And this number is going to go down 1. I can put 1 less in this box. So that was a 4 in that side. And I decided I was going to carry on doing that. So then I put 1 more in this box, 1 more than 3, and 1 less, and 1 more, and then 1 less. And I carried on and I carried on. Are there any more possibilities? The answer is yes, there are some other possibilities. But I would be using zeros and things in those. So hopefully you've got some of those possibilities in your book. You've written some down. And now we'll move on to our area. So just to recap, in yesterday's lesson, we talked about the area. And we said that the area is the amount of space inside a shape. So if we're thinking about like the playground, how much space to run around, or how big a piece of chocolate you've got, or how big a rug is on your living room floor, or whatever. So it's the area in the middle, okay? Not to be confused with the perimeter, which is the rim, which is round the edge. So the area is the space in the middle. Okay, so Jack uses his times tables even, to count the squares more efficiently. There are 4 rows. Mrs. Ogletree cannot speak today. There are 4 squares in 1 row. So if you look at this, 1, 2, 3, 4 squares in 1 row. And there are 3 rows altogether. So it's 1 row there and 2 rows and 3 rows. So 3 rows of 4 squares equals 12. So I did 4 times 3 or 3 times 4, and the answer is 12. Okay, so I've used my multiplication tables, my times tables, to count those squares more efficiently. Okay, so instead of going 1, 2, 3, 4, 5, 6, 7 like that, it's a perfectly reasonable way to do it, but first of all, there won't always be the squares, and so it gets tricky. And secondly, it takes quite a long time, and we might count 1 twice and make mistakes. So it's just an easier, quicker way to do it. So we do how many squares there are in a row times how many rows there are. So in that case, 4 times 3 is 12, or 3 times 4, because it doesn't matter which way around you do your multiplication. We're going to use Jack's method to find the area of this rectangle. So pause here and see if you can use the same method to find the area of Jack's blue rectangle. Off you go. Okay, so hopefully you counted how many squares there were in a row, and there's 1, 2, 3, 4, 5, 6, 7, 8 squares in that row, and there are 2 rows. So there are 8 squares and 2 rows. So if I do 8 times 2, I know that that is 16. So I know that there are 16 squares without counting them all individually. Okay, so I had 8 in a row, times it by the 2 rows, and I got 16. Okay, so let's move on. Find the area of these shapes. So you're going to pause and you're going to try and find the area of these shapes. Try using Jack's method when the shape is a rectangle. So some of these are a rectangle, and you can use Jack's method for working those out, and the others you'll have to count the squares on the screen. Okay, you can just write the colour in your book, so just write green or orange, pink, whatever. This one here, don't get caught out, it is a rectangle shape, but the middle is missing, isn't it? So you can't do Jack's method for that one, but you can do his method for that one, and you can do his method for all of those ones. So pause here and see if you can work out the areas. Okay, so this one is a rectangle, so we can use Jack's method for this one. So there's 1, 2, 3, 4, 5 in a row, and there are 2 rows, and I know that 5 times 2 or 2 times 5 is 10. So I can put there. Now, if these are all centimetres, centimetre squares, and they're all that length. If each side is centimetres, then we can put centimetres squared on each one. There we go. Okay, and then this one, let's have a look. I'm going to get my pen for this one because it's not a rectangle, so I'm going to have to count the squares. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that one is 12 centimetres squared. And you might have noticed that I tried to count them in a bit of a sensible order, because sometimes if we just sort of start drawing dots all over the place, we still might miss some out. Okay, then this one, I'll get my pen again because it's not a rectangle. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that was 12 centimetres squared. I'm not going to write centimetres squared after all of them, I don't think, because it's going to take me ages and you'll get bored of watching me write it again. So this one, my pen, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that one's 10 centimetres squared. And then 1, 2, 3, oh, that dot's in the middle, 4, 5, 6, 7, 8, 9, 10, 11, 12. Centimetres squared again, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's interesting, isn't it? Some of those shapes have the same area, but they look really quite different to each other. It sort of depends how the area is spread out, doesn't it? So, okay. Now these ones we can use Jack's method, okay, our multiplication tables to help us. So it's 4 rows with 3 in each row. So it's 4 times 3, and I know that 4 times 3 is 12, so I can do that one. And then this one, 1, 2, 3, 4, 5 rows with 2 in each row, so it's 2 times 5 or 5 times 2, and I know that's 10. And then this one, 1, 2, 3, 4, 5, and then there's 4 rows. So there's 5 squares in 4 rows. So I can do 5 times 4 is 20. Okay, so I did those, you might have noticed, much quicker, because I could just use my multiplication tables, my times tables, to work those ones out. Right, let's move on to this one. Dexter has taken a bite of a chocolate bar. Who can blame him? The chocolate bar was a rectangle. Can you work out how many squares of the chocolate there were to start with? So I'll give you a little hint. Use Jack's method and you should be able to work out how many squares there were to start with. So pause here and have a try. Okay. Hopefully you have an answer for me. Now, I can see that Dexter's chocolate bar had 5 rows of chocolate, 5 squares of chocolate in 4 rows. So I can't just count the squares because some of them aren't there. And it'd be really tricky to try and draw those back in. But I can see there's 5 squares in a row and there's 4 rows. So I'm going to use Jack's method and I'm going to say 4 times 5 is 20. So I think that there were 20 squares. Okay, because 4 times 5, I can see that there were 5 squares, I can see that there were 4 rows, and if we put that back in, then it'd be 4 times 5 would be 20. So the answer to the question, how many squares of chocolate were there to start with? There were 20 squares. Okay, moving on. Can I find the area of shape A? Okay, so again, for the purposes of this question, we're going to assume that 1 square is 1 centimetre squared. Okay, so I would suggest you use Jack's method and use your times tables. So count how many are in this row. Okay, and then times how many squares are in each row by how many rows there are, and then choose your answer from the bottom. Okay, if you're not sure, you can just count the squares. Okay, so I'm hoping that you realise that there were 5 squares and, just checking for myself, 5 rows. So I did 5 times 5 is 25. And 5 times 5 is 25. That means that this one must be the correct area of that shape, 25 centimetres squared. Okay, so your task for today, silver task, is this one. Find the area of each shape. Try to multiply the length by the width. So how many squares there are in a row? In a row. How many squares there are in one row, and times it by how many rows there are. Okay. So this one, for example, would be 3 times 2 because there's 3 squares in a row and there are 2 rows. So 3 times 2 and so on and so forth. In your book, you don't need to draw the rectangles out. You can just write number 1 and then next to it put the sum. So you would write number 1, 3 times 2 equals 6. And then that's your first one done. Okay, and do the same for the others. So if you're going to do silver task, pause it here and do that now. Okay, moving on to gold. Gold is a bit like Dexter's problems. You're going to have to use Jack's length method for this one, where you do length times width, because some of them have been ripped, the shapes. Naughty, naughty person that ripped the shapes. So here, for example, 1, 2, 3, 4, 5 in a row. And how many rows are there? Well, that bit's been ripped. So I'm going to look on this side because I know that this side is going to be the same as that side because it's a rectangle. So it'd be 5 times 3. Okay, so I'd do 5. So I'd write number 1, 5 times 3 is 15. And you call that one number 1, and that one number 2, and that one number 3, and that one number 4, and so on. And so again, you can just write the number in your book, the number of the rectangle, and then write the sum that goes with it. So number 1 would be 5 times 3 equals 15. That's your answer. Okay, so pause it here and have a go at that. If you haven't had a go at silver, you definitely need to have a go at gold before you move on to platinum. Okay, so pause here. And then for platinum, this rectangle has been ripped. What is the smallest possible area of the original rectangle What is the largest possible area if the length of the rectangle is less than 10 squares? I would suggest you have a go at drawing that rectangle out as to what you think the smallest rectangle could have been and potentially the largest. Okay? If the length of the rectangle was less than 10. So it's less than 10, not up to 10, so it's going to be between 1 and 9. All right? Have a go at that, and then you'll be all done for today. Well done, and I will see you tomorrow for some more area stuff. Okay, bye-bye.